What is the solubility of MOH2 in pure water? MOH has a KSP of, I believe that's 5.45 times 10 to the negative 18 here. I think just the formatting here is off. So I want the solubility of this. So KSP, or what the molar solubility is what I care about here. It's 5.45 times 10 to the negative 18. And again, what I'm going to have to do first, I'm going to have to write down my my chemical equation, right? So I have MOH here, or MOH2, sorry, is going to again dissociate into two things, right? Because again, it's going to be soluble in water. OH is my hydroxide ions, so in this case, this is my anions, which means my M has to be a cation, right? So M here plus this is OH, 2 OH minuses, right? 2 OH minuses. And if I have 2 OH minuses, I'm going to have to balance this charge here, which means this charge has to be a 2 plus charge here. So here is my solubility kind of equation. And what I can do here is I can solve for, again, the molar solubility, right? So what they're doing here is, again, they wrote this as S and 2S here, or you can write them as X's. It doesn't really matter. I personally write them as X's myself, so I'm going to use X's here. So, and again, we don't get a starting concentration here, so you can say that this here is simply just X, this here is X, and this is 2X here for 2 hydroxides here. And then what you can do is you can write your KSP equation here is going to equal our basically the product of these products, right? Sorry, the product of the products, which is kind of weird here. But this here's M2 plus times OH to the power of 2 here, because I remember my coefficient here is 2. I need to be able to reflect that in my KSP in my equilibrium equation here. This here is simply just X. This here is 2X squared. So simply what I'm going to have is X times 2X squared here is 4X squared, which is going to be, in total, X times this guy here is going to be 4X cubed here. And this will equal, again, my KSP. And all I'm going to have to do is simply, and because I'm given my KSP here, I can simply just solve for X, right? So I can plug in my KSP, which is 4.45 times 10 to the negative 18 equals 4X cubed. I can divide both sides by 4 here. To give me a second, divide by 4 would give me, this here is 1.3625 times 10 to the negative 18 equals X cubed. And I can cube root both sides to get my answer here. In this case, X here is going to equal 1.11 times 10 to the negative 6. And this guy here is going to be our molar solubility for our solution. And as you can see, X here is 1.1086 times 10 to the negative 6. I wrote 1.11 just to round it off to the nearest 100th place. So this solution here is correct. Again, they did the cube root and whatnot. I simply just used my calculator here, so it doesn't really matter. Usually you're given the calculator, so you don't have to do this tedious step here. It's actually probably impossible for you to do this by hand. So this here solution is correct, or it's not impossible, but very, very, very tedious here. So solution is correct. Great analysis.